So now the third question, this one is from the chapter of vectors, and this is from the first part of vectors. Vectors got three parts, right? Vectors algebra, and then you have vectors lines, and then you have vectors planes. So usually these two, they will have their own question, and then you have another question that is purely vectors algebra. Most of the time, most A-level papers have two vectors question, and one of them will be this, and the other is this. So right now we're doing this one. No need to visualize lines and planes. Vectors algebra are pretty straightforward. For the first one, given that A cross B is equals to 4A cross C, show that B minus 4C is alpha A, where A is scalar. Very simple, just throw this guy across to the left hand side, A cross B minus 4A cross C equals to 0. Factorize our A cross, I will get B minus 4C, right? Because if you expand this bracket, you will get back this. Then what does this mean? When two vectors cross together to give you 0, this means that they are parallel. So A dot B equals to 0 means that they are perpendicular, and A cross B equals to 0 means that they are parallel. So this means that this is parallel to this, which means that this is a scalar multiple of A, which is what they want. Next part, hence evaluate B cross C given that the area of triangle OAB is root 126 and alpha equals to root 3. So we know that B minus 4C is now root 3A. So let's draw triangle OAB. OAB. This is root 126. Find B cross C. Now there are many ways to do this. You can make C in terms of A and B. C can be written as B minus root 3A. And then I'm going to bring this, I'm going to put it inside here. I will get B cross C equals to B cross C is now this. So B minus root 3A. Expand this, I'll get B cross B. B cross B is actually 0 because B is parallel to B. So I'll get 0 minus away B cross root 3A, which is root 3 B cross A. Negative B cross A is the same as positive A cross B. So this simplifies to just root 3 A cross B. Now what is A cross B? The clue to finding A cross B is actually this triangle here, because for this triangle to have area of 126, this means that OA cross OB times half is equals to root 126. So what is A cross B is equals to 2 root 126. So this part is 2 root 126. Simplifying this would give us root 378 over 2. So far everything is nice and easy, nothing very complicated. Give the geometrical meaning of mod B cross C. You can think of it as two ways. You can think of it as twice the triangle OBC. So if you say that this is twice the area of triangle OBC, I mean that is a correct answer but not the best answer. The best answer you can give is actually to say that this is the area of the parallelogram with OB and OC as adjacent sides. So the answer to part 3 is area of parallelogram formed with OB and OC as adjacent sides. That's it for the 1 mark. Final one is also given that B is a unit vector, and then they bombard you with a bunch of extra information. B is length 1 A is length 5, C is length 2, and B minus 4C is equals to root 3A. By considering B minus 4C dot B minus 4C, find the angle between B and C. If they ask you to consider it, so of course, just go and use it. First of all, think about what is A dot A. This is equals to mod A cosine of angle between A and A, 0. What this is simply just the expansion of the dot product written in modulus cosine form. This will give us mod A square cosine 0 is just 1. So remember this, A dot A is equals to mod A whole thing square. Why I'm using this is because you notice that this is B minus 4C, this is also B minus 4C. So B minus 4C, when you dot it, must be equals to mod B minus 4C whole thing square. So what's so special about this is because we can actually find out what this value is. When I expand everything on the left hand side, all should be clear. So and we'll expand it normally like that, like that, like that. First thing, B dot B. What is B dot B? Using this, I know that is mod B square. Next item is just B dot negative 4C, which is negative 4 B dot C. In dot product, the order doesn't matter. It's not like cross product, where B cross A is negative A cross B. So dot product, you can just go ahead and just write it as B dot C, C dot B, doesn't make a difference. So the next one, negative 4C dot B, we'll get negative 4 B dot C again. Finally, we'll get 16 mod C whole thing square. Now what is this? B minus 4C is actually root 3. So this becomes root 3A whole thing square. A couple of things that we know. Let's find out what we know. We know this is just 1. We know this is just 2. We can expand to find this is just 3 mod A square. So we also know this. The only thing we do not know are these two. And if we were to expand this dot product, the cosine of the angle between B and C will come out. So let me show you what I mean. Mod B whole thing square is just 1 minus this is 8B dot C. And then we plus 16 times 2 square, 16 times 4, 64 equals to 3. Mod A whole thing square, 25. B dot C is equals to, on the left you will just get 1 plus 64 minus 75, negative 10. And of course B dot C can be written as mod B mod C cosine of the angle between B and C, which is the one they want you to find, angle between B and C. And this is equals to negative 10 over 8. Mod B is 1. Mod C is 2. So I'm going to bring the 2 underneath. I'll get this. So therefore, theta is cosine inverse negative 10 over 16. Press the calculator, you get 128.7 degree, 1 dp. And with that, we're done with this simple vector algebra question. Number 4, this is from the chapter of differentiation. To travel along the river now, an adventurer decides to use a log of semicircular cross-section of constant diameter c. So this is a constant number. To build a boat, the log is trimmed such that the uniform cross-section of the boat is isosceles trapezium. So this is the isosceles trapezium. Isosceles meaning this and this is the same. With base W and PS equals to QR. Okay, fine. Find an expression for the cross-sectional area of the boat, A meters squared, in terms of W and C. So to do that, the answer is just find the area of a trapezium, which is area equals to half sum of the length of the parallel sides, C plus W, multiplied by the height. The only thing here we need to know is what is this height. To find this height, go to the diagram, throw out the height. This is clearly 90. To find this pink color dotted line, of course you have to use Pythagoras theorem. So here, what is this value? This is your height. This will be C minus W over 2. And then you realize you can't find the height because you don't have this. Oh well, cannot do? No, it doesn't mean that. All you need to do is draw another line instead. So you need to create this line here and take a look at this triangle instead. After all, we are going to find the pink color dotted line, which is the height, right? And this green color line we just drew is the radius. If the whole thing is c, this will be half the radius. And of course, how long is this one? This will be half of w exactly. So if I were to draw this triangle here, this will be c over 2, this will be w over 2. How long is this height? Height would be square root of c over 2 holding square, c square over 4 minus w square over 4. Factorize out the square root 1/4, which gives us half. This will be just c square minus w square. So I'm going to squeeze this h into here, which will land me half times half, 1/4 c plus w, and then you have square root c square minus w square. And we are done with the first part. Find an expression for a. Next, show that w equals to 1/2 of c gives the maximum area of a. So this time round, ask yourself, which is the variable here? C is not the variable because they say c is the constant. So the only thing that's variable is w. We can either create a really flat looking boat, or we can create a deep boat like that. What they are saying is, in order to maximize this area, your w, if it's exactly half of c, that would be best. So here clearly we want to differentiate a. With respect to what? Of course you don't differentiate a with respect to c because c is a constant, so you differentiate a with respect to w. So let's do this differentiation using product rule. Hold 1, differentiate this, I'll get power bring down, copy, power minus 1, multiply by the differentiation of the inside, negative 2w, plus, do the opposite, hold this, differentiate this, I'll just get 1/4 times 1, and everything goes in. When does the maximum happen? Maximum occurs when dA, dw is 0. So this is equals to this. Before simplifying, let me just do some housekeeping. This is cancelled with this, and I'm going to bring the negative over to the right hand side to give me this c plus w times w over 4 square root of c square minus w square. This side I'll have this. Cross multiply both sides by 4, I will get this c square minus w square equals to cw plus w square. Bring this over, I'll get 2w square plus cw minus c square equals to 0. Factorize 2w minus cw plus c. So therefore, w is either equals to c over 2 or w equals to negative c. By choosing w to be this value or this value, it will give me a stationary point for area. In other words, either a maximum or minimum. So this doesn't make sense because your w, this length here, w, cannot be negative of c. So we're going to reject this. So that leaves us with this answer, w equals to c over 2, which is what they want us to show. But they also want you to show that it gives a maximum, so you have to double confirm that this is indeed a maximum. How you do that? Go back to your dA dw. You can either differentiate it one more time or do the first derivative test, which is actually the better one. So to do the first derivative test, we just need to come up with your dy dx evaluated at w equals to c over 2, w equals to slightly less than c over 2, and w equals to slightly more than c over 2. This clearly gives us 0, because this is how we got the number w equals to c over 2 in the first place. What if we sub in a number that's slightly smaller than c over 2 into our dA dw? So before we do that, let's just write out dA dw at the side here. All we need to know is whether dy dx is positive or negative. So imagine we have a number that is slightly greater than c over 2, 0.6 c for example. If w is equals to 0.6c, your dA dw would be negative 0.6c times 1.6c over 4 square root c square minus 0.6c whole thing square. C square minus 0.36 c square will give you 0.64 c square plus, so same thing here, 0.64 c square. Simplifying this will give us, then this will become, so here you will get negative 0.56 c square over 4 square root 0.84 c. So you can cancel, just like here you cancelled the c square with the c at the bottom to leave you with c on top. Here you will get 1/4 square root 0.84 c. Then all you need to do is press the calculator. Negative 0.56 4 root 0.84 plus 1/4 root 0.84. You end up with a positive number. Here, positive, so the shape looks like that. So this means that this is indeed a maximum because the curve looks like that. This is a maximum point. Now, the thing is, in exam, you're not going to go through all of these, right? The trick here is save yourself some time. You know it's going to be a maximum, okay? Because that's what the question says. Prove that it is indeed a maximum. So when you are about to do the first derivative test, you already know the answer is going to be like that, and then come down. So you can write this out like me. You will spend a lot of time. So what I suggest is you sort of blur out this part. If you really don't have time, no worries. Just don't write out this one. Just say using GC, dA, dW is negative. Here I need to show you this because if not, then you won't be convinced. Just choose any value that is slightly to the left and right of 0.5. Just write it out and then say using GC, dA, dW is negative. The examiner won't come and ask you, how do you use GC, right? What did you press inside? They won't ask. So if you're really running out of time, just write this thing out. Last question of this video, parametric equation. Find the coordinates of the point on a curve where the tangent is parallel to the x-axis, meaning when your tangent is horizontal. In other words, dy dx equals to 0, a horizontal line. And the coordinates of the points where the tangent is parallel to the y-axis, in other words, vertical. Dy dx, undefined. Of course, here we will need to do dy dx no matter what. So let's go. Dy dx is just, you need to find dx dt first. 3a cosine t power 2, differentiate the inside, I will get negative sine t. Dy dt would be 3a sine t power 2, differentiate inside, cosine t. Take this, oops, this is a t by the way. Take this, divide by this, I will get dy dx. 3a is gone, I'll get sine square t cos t over cos square t negative sine t. A lot of these can be cancelled. This can be cancelled with this can be cancelled with this to give us sine t over cosine t, which is simply tangent t. So back to the question, when is dy dx 0 and when is dy dx undefined? Defined. Because those are the two conditions for us to find the horizontal tangent and the vertical tangent. For dy dx equals to 0, which in other words means tangent t equals to 0, t has to be 0. And for tangent t to be undefined, this means that t has to be pi over 2, because everyone knows that tangent pi over 2 is undefined. Any other answers? Yes, there's actually one more answer, because if you take a look at the range here, t can go all the way until pi. So be sure not to miss out on this answer. Tangent t equals to 0, t, it's not only equals to 0, but t can be pi as well. So a grand total of 1, 2, 3 answers. Using these values of t, you can go back to the equation, parametric equation, to find out the x and the y value for each of these t. So coming back here, this will correspond to when t equals to 0, x will be a times 1, y will be a times 0. So it's a 0. What about this particular value, pi? Cosine pi is -1. -1 cubed is -1. So your x value is -a. Your y value is still 0. What about for tangent to be undefined? Pi over 2. Subbing in pi over 2 here, this will give you 0. This will give you 1, a. So here is 0, a. There are 3 points. These 2 points are where the tangent is horizontal. This point is where the tangent is vertical. And then they say hence sketch C. Well, of course you can just use the GC. I'm going to use a equals to 2 instead of a equals to 1 in my parametric graph, so it looks something like this. I prefer the number 2 because you can see it manifest in the graph a bit better. So if you take a look at the graph, so you get this simple shape. Going back to the question now, since we already know the shape. We're not supposed to use GC, by the way, because they say hence. So using GC is sort of like a cheat method for us to check our answer instead. We know it looks like that, and then it looks like that. So x, this is your y. Now take a look at the values that we have calculated. We will have horizontal tangents at a0, right? Clearly, this is a. We have another horizontal tangent at -a0, right? Because see, there's a tangent here. So therefore, this stationary point is -a. Notice here, you get a vertical tangent because of how the curve is, which is actually this, 0a. So as long as you write this, you'll be correct. The GC actually just tells you what kind of shape it is. Okay, now the third part, point P on the curve has parameter P. Show the equation of the tangent at P is this. Equation of tangent. To find equation of tangent, which is y equals to mx plus c, first of all, find m. M is you sub in the corresponding t value into your dy dx. Point P has parameter P, so we sub in P into your dy dx. For example, if they say it has parameter 2, this means that I'm going to sub in t equals to 2 to find the dy dx. This time around is just a mystery number, P. What is your dy dx? Your dy dx from above would just be negative tangent t. When t is equals to p, what is your dy dx? Your dy dx will now be tangent p. They put all these values, they give you all these unknown constants in hope that they will confuse you. They just don't give you nice numbers. They keep giving you letters after letters in hope that you will get confused. But please keep a clear mind of what's going on. P is just a number that you don't know. It is not a variable anymore. We know that this is negative tangent P. The gradient is negative tangent P. What is point P then? Just need to sub in t equals to P, right? When t equals to P, gradient is this. Point P will be a cosine cube P. A sine cube P. Then just throw all this information into your y equals to mx plus c. Y equals to m x plus c, which gives you c equals to a sine cube p plus, I'm going to cancel this, a sine p cos square p, and therefore your gradient formula would be y equals to negative tangent p of x plus this long chunk. However, you notice that's not what they want you to show, so you got to brainstorm a bit and manipulate this until you see what they want you to show. This is the endpoint, what we have now, y equals to negative tangent p x plus a sine cube p, a sine p cos square p. I'm going to bring this over to the left hand side, so x and y lives happily on the left. Y plus tangent p x is equals to this whole string. Then multiply throughout by cosine, I will get this. Tangent times cosine gives you sine p. So this is x sine p. Multiply this whole thing by cosine. Okay, this is whatever, right? Now, take a look at both of them. They have a in common, they have sine in common. So I'm going to take out both of them at the same time. What's left inside if I take out a sine? This will be sine square p, and then this will be cosine square p. Wow, happy days, because this is just 1. So this is gone, and then hence shown. Okay? Last question, tangent at P is perpendicular to the tangent at another point Q. So tangent at P is perpendicular to another tangent at point Q. Now finally, they reveal to you what is the mystery value of P. P is actually pi over 3. So you'll be able to find the gradient at P, right? Which is tangent, negative tangent P. You end up with negative root 3. So if the gradient at P is negative root 3, this means that the gradient at Q is positive 1 over root 3, am I right? So therefore, if they want you to find the value of the parameter t at point Q, very easy, throw this in. Since dy dx, we know that it is 1 over root 3, which is negative tangent t. This is my new mystery parameter for Q. So equate tangent t to 1 over root 3. So therefore tangent t is negative 1 over root 3. We know t is in either the first or second quadrant. And since it's negative, so t has to be in the second quadrant right now in order to solve this. So tangent inverse 1 over root 3, the basic angle is 30 degrees or pi over 6. This is the basic angle. So t has to be in the second quadrant, therefore it is 5 pi over 6 because it's negative. So that's your answer. Thanks for tuning in. I'll see you next video.